Hey everyone, today I want to talk about integration testing with containers in Java. We've all been there. You've been tasked with making a one-line change to some code in production, and then you pushed to production, and now you broke production. I want to help fix this. The goal of this video is to help you write integration tests for your Java applications, which will make modifying your code easier in the future. I'm going to cover a few topics in this video. First, I'm going to talk about why integration tests are important. Then I'm going to give a brief explanation of networking in Docker and how this relates to our tests. Then I'm going to walk through the code and explain the tests and then execute them. Finally, I'm going to give you some tips on debugging the integration tests. All right, let's go. Integration tests take all of the required resources for your application and test them together as a group. Let's talk about some of the advantages that integration tests have. Running your applications in an environment closer to production is really important because the closer you are to simulate production, the less surprises you'll have. Testing application frameworks. When using things like Spring where configuration can be driven by properties, I feel like it's safer to test these in the full running application and see how they respond. And it prevents you from going mock crazy. If you've ever written unit tests that require more knowledge of mocking than the actual logic you're testing, then it might be better to consider that for integration tests. Some disadvantages for integration testing is that they typically take more time to run when compared with unit tests. They also use more resources, think RAM, CPU, because you're spinning up an environment that's similar to the environment that the application needs to run fully. And some external resources may be impossible to replicate. You may have a vendor resource in production that you just can't create in your dev environment. How do containers help integration testing? They allow you to spin up resources for your tests that would have previously required a dedicated machine, like a MySQL instance. Because containers are ephemeral, you get the benefit of sanitized resources between your tests. So every time you spin up your MySQL container, you're guaranteed that it's a brand new database. And because containers can run anywhere, you can run your tests locally or on a build server. All you need is Docker. Alright, so now we're going to talk about networking with containers. If you're familiar with this topic, then I suggest you fast forward to the next section. When using Docker, you can create a network for multiple containers to communicate with each other. If you want to communicate with your container from inside the Docker network by name, you can assign a network alias to the container. So in this case, the container with the network alias app can talk to the container with the alias MySQL on port 3306. To communicate with a container from outside the Docker network you created, you must expose a port, which will map from a port on the container to a port on the host. The integration test that I'll be showing you shortly will make use of the exposed port to communicate with the app running inside the Docker network. We also have an exposed port for the MySQL container. Later on, I'll be showing you how you can connect to this exposed port and view the data inside of the MySQL instance that's running. Let's take a look at our Spring Boot app. This application has some endpoints which get and store users. Let's go into the controller. The controller has methods for adding users, listing all users, getting a count, and retrieving a user by user ID. The controller is connected to a user repository, which is responsible for the create, read, update, and delete operations for users. The user DTO object has an entity annotation that tells Hibernate to make a table out of this class. If we look in our applications.properties, we see something called Spring JPA Hibernate DDL-auto. We have it set to create. This will create the DDL for the table when we start the Spring Boot application. In the case of our test, this is perfect because when we initialize a MySQL instance in a container, it's empty. You probably want to modify this if you're going to production. We also have some stuff here that handles the Spring Boot actuator. This sets all the endpoints to be enabled by default. We have that set to false, and we're explicitly enabling the health endpoint. As you can also see, we have the data source URL and the username and password. These are the basics of this application. We're using the Spring Boot Maven plugin to repackage the app as a Spring Boot jar. Then we have a Docker file that builds an image with our application using the Dockerfile Maven plugin. The Maven Failsafe plugin is responsible for running the integration tests. For the integration tests, we're using test containers, which is a Java library that orchestrates containers during test execution. Alright, now let's take a look at the test. So the before class annotation runs this method only once before the tests start. So inside this method, we have the MySQL container as a generic container that we're creating, which means we're specifying the image that should be pulled. We expose port 3306, which MySQL listens on internally, so we can connect externally on the host to debug. We attach this container to the Docker network that we created above. And then we're using the class path resource mapping. This allows for files inside of the resources folder to be mounted inside of the container. For these two cases, this Bootstrap SQL is responsible for creating the database, creating the user, and then granting the user access to do everything on that database. This users.sql we'll talk about a little bit later. Then we start the MySQL container. This is the app we built in our POM previously. We have the expose port 8080 because this is what the application is listening on internally. And we're also using the same Docker network. For the data source, we're overriding what's in the properties file with this MySQL :3306 because this is the alias that we're connecting to in the Docker network. We enable logging for the application. Then we set the base URL. This is how we'll access the application from outside the container. All right, now let's take a look at some of the tests and then we'll run them. The teardown method runs after every test and truncates the user table. This is needed for scenarios where we need to ensure there's no leftover data from previous tests, like assertions on counts. One of our first tests is to ensure that the Spring Boot actuator endpoint for health returns a 200. The next one is to make sure that the info actuator endpoint is not enabled, so we should get a 404 there. Then we have tests to add a user and then a list of users. We have a test that ensures that adding a user with bad data doesn't succeed. For the count users test, we run the users.sql file in the MySQL container, then call the count endpoint. We assert the number of users returned from the API matches the number we inserted with the SQL. For our compare test, we insert a user, get the user ID back, and then query for that user again and compare the original user to the user that we got back. And because we have a comparison method on the user object, we're able to see if they're the exact same user. Okay, now let's run the test. Before running the test, you should make sure that the Docker daemon has started. To run the test, from the command line, type maven clean verify. This will compile the application, recompile the application using the Spring Boot Maven plugin, build a Docker container with the jar, and then run the Maven failsafe plugin, which will run the tests. And now you're seeing that the tests ran and they're successful. Now let's suppose that this application is production facing and we have a developer and they want to enable one of the Spring Boot actuator endpoints, but they're not sure how. So they go into the application.properties and instead of having it enabled by default equal to false, they set it to true. So that's great. The endpoint that they want is now exposed and they think that everything is fine. Well, it turns out that now this made it all the way to production. Here's how your test can help stop that. So you run your Maven clean verify again. It runs through building the container and then executing the tests. And because one of our tests explicitly say that the info endpoint should not be exposed, this test is going to fail. This is where I feel like integration testing is really important. For certain things like property files that you're going to be changing that you really can't unit test, I feel like integration tests can help you from making mistakes and stop you from pushing them to production. Let's talk about how we can debug our integration tests. So if you're using IntelliJ or Eclipse, you can go ahead and create a debug profile with a class as the application IT for integration tests. Click on debug and this will execute the test. Now that the tests hit this breakpoint, we can open up a terminal, type docker ps, and that shows us the running containers. For the instance of MySQL, we know internally it runs on 3306, but externally is running on 32786. I can open a SQL client, I can put that port in there, and I can connect. And I can choose the database, and I can choose the table. Because we have the after method that runs and truncates the table, each test will get a fresh copy of the user table. So we're going to go through, we're going to set another breakpoint, and we're going to let it run all the way until it actually inserts the users. Now we go back to the SQL client, we'll refresh, and see that we've inserted a bunch of users. When we hit a breakpoint on the next test, we can refresh the database and see that the table is empty because of our after method, which truncates the table. Also, while the tests are running, you can open up a session inside of the container and then execute commands. Since our tests are still in this debug state, we can run docker ps, and then we'll get the container ID. Let's say, for instance, we want to take the one with the app. So we'll copy this container ID, and we'll run docker exec -it, the container ID, and bin/sh. And now we're in the container. So we can actually do an ls, and we'll see that we have the app.jar. These containers are bound to the lifecycle of the tests, so they'll disappear as soon as the tests finish, but it's cool that we can still jump in. The code shown in this video will be available on my GitHub page with a link in the description below. I hope you enjoyed this video and you took away at least one thing that can improve your integration testing. Thank you for watching. Peace.